Hi, this is Bits and Pieces, the official podcast of Component Supply. I'm Kristen.
And I'm Mark.
And today we're going to do our third episode of our series, There's No Such Thing as a Stupid Question. We love when engineers and product designers come and ask us questions. And a lot of times, because of where we are in the space, early R&D, we get a lot of apologies from engineers saying, we're sorry, this is probably a stupid question. And I do that too. That's a default for me. But it shouldn't be, right? Because we're all learning. We're all trying to become more efficient. So sometimes you just have to ask the stupid question. So we love saying the stupid thing out loud. So we're going to try and answer some of the questions we get related to our wire products. No questions too basic. We don't feel stupid when you talk to Component Supply. My favorite thing is trying to simplify complicated or otherwise complex concepts, and so I love a stupid question. What about you?
I have wrestled with calling them stupid questions.
Well, for sure.
Because we actually, if you think about it, here at Component Supply, we have very intelligent people that work for us, and we work with some of the smartest people on the planet.
For sure.
Our customers truly make up the smartest people in the world. So we've talked about this. We've talked about moments where we say like, oh, it's hard to be the smartest person in the room, right? And make the definition clear. That the smartest person in the room is not the person who seems to have all the answers. It's the person who knows when it's time to open their mouth and ask the next question.
For sure.
That is the smartest person in the room. And so, in that we can use it towards the kind of the pithy way of saying, like, there's no such thing as a stupid question. What we're really saying is this is for the smartest people in the room that know when it's finally time to open their mouth and ask a question to move to the next level. So I would define it that way. Sorry.
Yeah, no, that's perfect. And we loved it. It is perfect. And it's true. We love when people ask the questions early. And that just is a smart move.
It's a smart move.
To ask the questions as early in the process as you can. And I think whether we're hiring someone for Component Supply or, if I'm on LinkedIn or just in a conversation with someone and they say something along the lines of, I'm a lifelong learner, I'm like, well, we're kindred spirits. Let's learn together. So these are some, maybe for you, some of you may be really simple questions, but just keep in mind that all of these are the answers to questions that we've gotten over the years with conversations related to our wire products particularly. So the previous ones, we covered mesh, we've covered hypodermic tubing. So today, wires and mandrels. So I say wires and mandrels, that kind of takes us to our first question. Mandrel, wire, bar. We talked about this last season on an episode. Yeah. Like, do you have this bar? Do you have this mandrel? Do you have this wire? Component Supply routinely refers primarily to wire, though we've had to add some mandrel terminology simply for people to be able to find our components. But for us internally, it's wire. It's GWX. That's our stainless wire. It's Nitinol NW wire, and we call it that because tubing has a hole in the middle. Wire doesn't. And when we think about a mandrel, we're thinking about the application. A mandrel is not the only medical device application for our wire. They're used in various things. So we just want to caution you, yes, if we see that you're asking for a mandrel that's this diameter, we're going to look on our wire shelf and find the component for you. And then you have bar, and that's more defined kind of in the industry as a larger diameter, usually like 60.
Yeah, I mean, there's, this gets really complicated, but it isn't. It's actually, if you look at, take just material properties, just materials in itself, right? And you'll go out and you'll find somebody that says, all of a sudden they say they have this hollow bar, and you're like, okay, but that's a tube. Why would they call it that? And ultimately it kind of goes down not to the medical device industry, but the construction of product. And so, if you just look at materials and shapes, you really fall into two categories. You have a bar and a rod. That's what you have.
Yeah.
And a bar is technically, this is why it's so confusing, technically is not round. A bar would have some shape. It'd be hexagonal, it'd be square, it'd be rectangular. Yeah. A rod is a round rod. And so everything at the highest level that we sell falls into the rod category. And now we just back down and say, okay, what's commonly known in if you want to just call it industry jargon. You would have, no one is going to say, oh, that's, what kind of rod do you sell at Component Supply? Right. We look at there's lines between somebody decided some size that says, okay, well, below this is a rod and above this is a wire. And then somebody else said, no, that's not the right size.
Yeah.
And so it gets confusing on that. The reason they called it hollow bar was because it was gun drilled rather than run through like a a drawing die and then welded. So those terms exist, and they get really, really confusing. And so when you all of a sudden you come in and you ask what you're saying, this question of like, what is it? And then we threw on top of it like a mandrel. Mm-hmm. Ultimately, we're going back to a raw material. We sell a raw material. Mm-hmm. We happen to call it a wire. Mm-hmm. That wire can be used for a spring. It can be used for a mandrel. It can be used for a guide wire. Mm-hmm. And so that's the hard part, is we're using application terminology to describe a raw material.
Right. Yeah. That's right. Or they're giving us a drawing that calls out a stylet, or that calls out, whatever they're calling that component in their device. And so navigating that a little bit. For me, in really simple terms, bar it's the same material, right? It's going to be 304. It's a spring temper, but it because of its diameter, it's just not. It doesn't feel as flexible. Like, you don't notice that flexibility. It's pretty stiff. So it's a design decision. Like, don't get hung up on vocabulary, right? Think about your material. What material I need? Nitinol, wire, a coating, nitinol, stainless, or some kind of coated wire. And don't get lost in the application when you're trying to source material. Just think about your material and your diameter. You should be good to go. Let's move into the taper questions. So it's less of maybe a specific taper and getting into the nitty-gritty of profiles and what profiles work. It's more like, I've gotten no quotes from a lot of suppliers or manufacturers. Why am I getting no quotes? And I think there are kind of two ways that a tapered mandrel can be tricky. We see a variety of maybe an overall length of like a 72-inch kind of taper, and a long of a wire that has a long taper over the scope of the whole device. Or we have such a sharp taper that it almost looks like a step. Like, it's so sharp. So in those situations, you have a couple of manufacturing considerations. One is on our end as performing the secondary operation on this raw material wire, maybe what we prefer, what we see as levels of difficulty related to a long taper over a longer piece of the material, versus getting a request for a short taper, which very doable from our perspective, but might have challenges on your end for reflowing material together. So do you want to talk about that at all, from our shop's perspective?
Yeah, let's deal with the long gradual transition. So like a very flat angled taper. I went to a conference recently, and everyone's very familiar with design for manufacturing. I try not to use a lot of acronyms, so the whole DFM thing. But design for manufacturing is a big topic. That is new, but everybody likes it now. But they were interesting because they kind of brought up the idea of like the DFMM, design for manufacturing and measurement. And the reality is the way products and prints are being designed today, and our ability to measure today has added this level of, it's great that you're designing it for manufacturing, but you really cannot stop there. You have to, in the design phase, you have to consider the measuring side of it, because it's really simple in SolidWorks and AutoCAD to just throw something out 4 decimal places. And then there's not a gauge that can accurately read that. And so what happens is when you get a long transition, finding where that transition starts and stops starts to get really dicey on the gauge. And if you think about it, in certain applications and in certain taper lengths, your starting material, which might have a tolerance of plus or minus 0.3 or something, if you call out a transition length of 6 inches or 10 inches, or we've done some of the transitions lengths 30 something inches long. Right. You can start the transition and several inches in, you can still be in tolerance to the base wire. Right. So where does that actually start? Who defines that? And what is the true definition there of where the starting point and the stopping point of your transition is? It's not making it. Making it's the equipment that's out there today, the technology, the skill sets of operators. We can make that. Can we communicate it back and forth? That's the challenge of those longer. That's the challenge of those longer tapers and longer transitions.
The engineer has spec'd beyond what measuring equipment can evaluate, and at least affordably. Or
they didn't understand the measuring, that process. And so this is where conversations come in of saying, hey, look, the answer is yes, but what are you going to measure? And let's make sure we're on the same page when we're measuring this.
Right.
You've asked us to do this, and maybe you don't care about those nuances, but maybe somebody in your incoming inspection does. And they don't understand as well. Getting on the same page with whoever's producing that part on those long tapers is really important, not from the manufacturing standpoint, but from the measuring and gauging standpoint.
Yeah. No, that's really good. Do you have any advice for engineers who are designing a device where the application is going to require that long taper? Aside from just having the conversation, is there some kind of
don't call everything out.
Yeah.
If it's one transition, you've got 3 unique sections. You've got your original, base, the wire starting point. You've got this transition, and you've got, the proximal end, whatever the small diameter is. Those have you've got some length that needs to be that. You've got some length that needs to be the larger diameter, and then you've got this in between. Pick 2 that are important, or 1 if you can, but don't pick all 3. Yeah. And the reality is choosing the taper length as your critical dimension. That's really probably more problematic than just picking one of the flats. In general, it's easier to see the proximal side, the side that the base wire material, but it doesn't really matter too much. Just don't pick too many, and don't put super tight tolerances, particularly on the transition.
Gotcha. No, that's good advice. So if you find that you're getting no quotes, again, we encourage the conversation. Hopefully we're not no quoting you. Hopefully we're asking some follow-up questions, or we're saying we'll take exception to some, angle or some tolerance. But if you are, that could be the problem, is that you have too many specs called out on your taper. We have the short taper request sometimes too. That's not as hard from our perspective to manufacture. We can see it really well. You can see those transitions. You can gauge it. The issue there becomes delamination in your reflow process, right?
So the I will say some of this wrong, so somebody who deals with this can correct me on however you deal with that. But when you etch, especially if you're using a liner, when you etch the liner, I want to say that it creates it's 30 degrees where that etching takes place that allows adhesion. So the minute you go beyond or get close to that, you've now, in essence, gotten to a point where there's nothing to move on to. There's nothing to grip onto. There's a potential space where that delamination can take place. And so those super steep tapers like that work against you, not in the grinding and the production of the mandrel, but in the catheter
down the line.
Construction part.
Yeah.
If you're not using it for that, then that doesn't matter.
Yeah.
But if you are, that is something to consider in the design. Is the transition there, that angle. You almost need to take into account what's going on with the etched liner. If you're using an etched liner, you've got to consider that, because it could potentially cause a problem, later on.
Yeah, that's really good.
And this is where talking to the companies that make the liners can give you kind of some. They're not grinders, but I mean we're not liner manufacturers.
Right.
So we have to rely kind of on each other in terms of what our limitations are and what we should be doing to make sure you're not winding up with problems in the future.
And it's one of the reasons it's nice to have. We have some quick turn grinding programs that we can offer to allow you to just test with one or just a handful before, making this whole design and then realizing when you get into it with larger volumes that it's not working for you. The reflow process is not working the way you intended it to work. Having access to smaller quantities is key for a lot of our engineers. So if you maybe have hesitated to reach out because you're not far enough down the line, we'd actually prefer you to have the conversation early and to test those transitions early on in the process so that you're saving costs down the road. Okay, let's move to material choice for mandrels. For us, we're typically seeing requests for mandrels made from either a stainless steel or a Nitinol wire. So there's some sort of either a taper performed on it or it's just straight. But why a stainless steel versus a Nitinol?
This is sometimes I wonder if this is. If there really is a reason, or they're just like that's the way we should go. Now, there's some material properties with Nitinol that are beneficial, right? Like the super elasticity, especially when you've in the reflow part when you take the mandrel out, that can be beneficial.
Yep.
It can be used more, more cycles.
If there's like a preset shape of any kind.
Yeah, that's.
Bend.
But I think a lot of times it's just a preference for. If you think about it, it's just a tool, right? The mandrel is just a tool. It's not part of the finished design. It is a tool. It's a tool used in the construction process. So anytime you can have a tool that lasts longer, we see it too, right?
Yeah, reusability.
We could use high-speed steel, high-speed steel cutters, or we could use carbide cutters. Why would we use it? Well, it's going to last longer.
Yeah. But I do think some people it's like using a name brand. Sometimes it's just because it seems like it would be better. It feels like it would be better. Nitinol is one of those things right now that everyone loves to talk about. It's, very popular. And I think there are really meaningful devices that it needs to take place. I don't always know that it's true for catheters. So sometimes if someone asks us, can we use stainless steel for this? Like we've spec'd Nitinol, can we change to stainless steel? A lot of times the answer is yes. It's not you're not using the critical characteristics of Nitinol for this mandrel application. So, if you're looking for a more cost-effective material, absolutely stainless steel is the right choice for you.
That's right. And, one of the things that we keep seeing is they're asking us to grind mandrels out of harder material. And I can imagine, no one is, all right, not no one, but I don't think they want to admit the confirmation there as they damage the mandrel as they're taking the shrink tubing jacket off. So they're damaging the mandrels. They want something harder that won't damage. They're looking for this. So again, it's tool longevity. and sometimes it is material properties. I think there's so a couple of reasons why you would choose Nitinol over stainless for a mandrel.
Yep.
But I think a lot of it has to do with preference, and outside of very specific applications. There probably are other. We don't construct catheters, so there probably are some very specific reasons why they would choose a Nitinol over stainless steel.
Please let us know. The more information we can get from our customers about why they choose our materials and for certain applications versus others, the more that we can share, the more we can make sure we have the right stuff on our shelves. Lots of different reasons. So again, don't just have the conversation because of a project you're working on. If you want to give us a call and be like, hey, you were way off on this podcast. This is actually why we use Nitinol. We would love to hear. Yeah. It would be great.
Other than, like I said, those two reasons.
Yeah. Yeah, so if there's something we missed, let us know. The one other thing I think about is occasionally, maybe not occasionally, a lot of times you're having this, there's some kind of coating put on it. If you're not using a PTFE liner, perhaps you're having your mandrel coated. And there might be a better coating for a Nitinol mandrel versus a stainless mandrel. We had Surface Solutions group on a little bit ago and kind of broke down some of those different coatings. Don't just call out PTFE because you always have. There are lots of other options, and there are some that are better suited depending on what your base material is. So again, the theme I think of our industry right now is like have the conversation early. And the truth is, I think so many of our R&D engineers are so busy just trying to source and get things that they really just don't have time for the conversation. That's one of the reasons we're trying to put more information out there for you, so you have access to it. But whether it's Component Supply or someone else, it seems to me, and I think you witnessed this, when you did some customer visits last week, people want to have the conversations. Getting it started is the hardest part. So don't hesitate to pick up the phone, get on the chat, send the email. Let's get it going so you're not down the line, wondering if you could have used something different. One thing I want to talk about are our end forms. A lot of times, particularly with mandrels that maybe don't have a profile, they're just a straight mandrel, but they're a custom OD, maybe with a tighter tolerance. A lot of times you all are requesting an end form and trying to decide what's beneficial. Is it the aggressive deeper? Is it the chamfer? Do I just need a straight cut? Do we need that full radius? And so a lot of times if you are asking us for some kind of radius, we provide a visual that's like a spectrum to pick from. Can you give us some insight about, when to use that full radius? We've talked a little bit about this in other episodes, but it is a question, so we couldn't leave it out of this episode. When is it okay to just have that straight cut versus when do you need truly a full radius versus something in the middle?
Yeah, I would say anytime you're dealing for the catheter construction, you should never have a straight cut.
I think Surface Solutions would agree too. Anytime you're sending something out for coating, it's better to at least have the broken edge.
Right. Now, whether or not you need a complete, a full radius,
fair.
That's where it starts to, sometimes I think they ask for it in terminology, but the reality is, why did you need it in the first place? You're really trying to just solve a problem, and I think a lot of times, obviously you don't want a square cut. It's got to have you've got to have some broken edge, and truthfully, just a typical deburr on the edge isn't really enough in that application. It needs to be more rounded, but more rounded versus a full radius, there's a huge construction, processing time and inspection more than anything that takes place there. And it's not just final inspection, it's in-process inspection and final inspection. And so, and all that to, in many cases, just to simply say, no, I just need to be able to, easily slide my operators to slide, all the components on really easily. Okay, well that doesn't need a full radius like that. You're adding a lot of cost and a lot of time for something you really don't need. Those are the things to consider.
It's very manual still.
It's still very manual. I mean, there's equipment that does it, but they're not efficient.
They're not efficient, or you have different setups for those things depending on your diameter and different time. We have to quote that, because
you have to look
the bigger
at
the diameter, the longer it's going to take.
Right.
And so, when I'm quoting, and thank goodness Courtney does a great job of doing this, but in our heads, we do kind of like, okay, how long is that going to take? Like you're trying to give, especially for some of you R&D, we're trying to do the best we can to make it cost effective because we know you're early on. But it is, if you can get away with not a full radius, not full rounded ends.
Well, what happens
you
you spec it in as a full radius.
Yeah. And then you're stuck.
But the translation down line, this is why this is why this design for manufacturing and measurement is so important. You spec it in. What happens is incoming inspection. Your quality department looks at that and says, okay, here's the drawing. It's calling out full radius, and so we know the diameter of the wire. We know what that end is supposed to look like, and so now we're going to put it on our Keon's machine, and it's going to inspect it. Well, guess what? If that's the way it's going to happen, that's the way it has to happen here.
That's right.
Which means we have to in-process inspect it, final inspect it to those specifications.
Yeah.
And all you needed it was to make it easy for the operator to slide the components on. And sometimes they need a full radius. I don't want to discount that. There are times that you need that level of precision. But designing it around what you really need, this is why we sent the picture with all the different, 1 through 14 different options where you can look at them and say, oh, wait a minute, okay, somewhere around there is what I need. Because all of a sudden, if you can live with, this bigger range, your price goes way down.
Yeah.
And your quality team can turn around and say, oh, okay, this is what I'm looking for, and set that up in their system. Or say, hey, I don't even have to, for that range, I don't even have to put it into our equipment. I can just simply visually inspect it, so it saves them money in process time. So anyways, I don't know if I answered the question or not.
I'm sure you got close.
Okay.
All right, so just kind of as a rapid fire, we talked about rapid fire review. We talked about the difference between a wire, a mandrel, a bar, a rod, hypotube.
We didn't talk about hypotube.
It's got a hole in it.
Well, we did talk about that.
We at least brushed on it because people are using hypodermic tubing as a mandrel.
They do, especially the larger sizes. Yeah. That's the benefit there.
That's why we had to include that one. That's just free. So we won't charge you for that. We'll charge you for the hypotube, but not the information.
Am I getting paid for this? I didn't even know I was getting paid for this.
I hope you're getting paid. Not by me, though. Do I always need a taper on a mandrel? You don't always need it. Depends on what it's being used for. Tapers are used to help you, easily remove the mandrel. There are lots of benefits for it. It's not a requirement just because it has a taper on it. Or a mandrel can be a mandrel without a taper, okay? It might have a step. It might not have a profile at all. It might just be a custom OD. So that's a question or a consideration that people have. How do I choose a mandrel material? Again, it's up to your application. We can't just tell you across the board. Everybody is different. Every application is different. And a lot of times we're only exposed to bits and pieces of your application. So, more information you can give your supplier, the better. Your suppliers, Composite Supply and others, we're dying to have conversations with y'all. We're trying to get in there early so that you're not having these, we hate it. We talked about this in previous episodes. We feel so bad when someone's like, oh yeah, that would have been good, but it's going to cost a fortune for us to do a redesign. So the earlier the better with all the conversations. Issues in the reflow process for when your taper is too short, issue with the secondary operations piece when you're contracting that out, if it's a long profile. So again, when you can loosen tolerances on the long stuff, do that. Make sure your taper is not too steep to give you the best result. Let me think. Anything else I wanted to talk about today? Any questions, concerns? Problems that you have? Any advice you would like to give?
No, I would rather, at this point, now you're diving into some very specific things, and the reality is, the answers are kind of always along it depends.
Totally.
It's hard to deal with that. And so this is where, these conversations don't usually last long. No. They really don't. And, most of the time we pull off the conversation in about 15 to 20 minutes. Mm-hmm. I actually would prefer if people just said, hey, why don't we book 15 minutes. We're going to block out 30. But
That's
we
for
understand
you, though.
people are busy. And so we would rather just say, let's just take 15 minutes. I'll share my screen, what I can share, and here are the questions. And, does everything look okay?
Yeah.
Do you have any suggestions before I just send it over? And this is what I'd like to do, but I didn't put it in the drawing. Something like that, and have that conversation, because we are moving into things that are just really specific, and it is like, well, it just depends. Okay, well, let's take 15 minutes and go through those. That it depends.
Right,
things.
but we wanted to share just because they are questions that we get. So don't hesitate when you have a question that you feel like is maybe you should know it already, or but yeah, it's hard to make a podcast on all of the what you have felt, what you have expressed are stupid questions, because they're so specific to your application. But we're not scared of diving in and dealing with those things. And like Mark said, it doesn't take long. We do 30-minute meetings, even though we can be in 15, because honestly, we run over. I don't like running over. So we give ourselves that cushion. Yeah. And hopefully that works out, so we're not late going forward. But whether it's a quality question or a profile question, feel free to reach out with us. There's no such thing as a stupid question. Get those questions asked early and go change the world.